Welcome to Syntax. We found somebody to explain what the hell Kubernetes is to us. And we're really excited to talk to David Flanagan today, who is a Kubernetes engineer. And I'll start with the story really quickly before I introduce him. We had the DMARC and SPF episode a couple weeks ago that I was prepping for, and I was making sure all my ducks were in line. And I was talking about how I had like domain aliases with two different domain names, and my SPF was working with one of them, but not with the other one. And I was, is this normal? And David jumped in DMs. He's like, hey, like send me an email. And he's analyzing the headers and checking things, and like immediately understood everything about these like server DMARC and all that crazy stuff. So obviously a pretty smart guy, does a lot of stuff on YouTube and on Twitter. And we'll talk about what all he does under raw code, but he's going to explain to us Kubernetes, servers, hosting. Hopefully you as a JavaScript or a full stack dev, as you think, maybe I should run my own servers. Maybe David will be able to help us today. So welcome, David. Thanks so much for coming on.
No, it's my pleasure. Happy to help, happy to be here, and excited to share some bare metal Kubernetes containers infrastructure as code nonsense with everybody. So.
Love that. Yeah. Yeah. Kubernetes is one of those things that it's come up enough on this show that we used to joke about. I mean, even Wes joked about it at the jump of this episode, that we have no idea what the hell it is. Or we just got in recently to like Coolify or self-hosting. And Kubernetes keeps popping up in that whole world of self-hosting. So really stoked to have you on to talk all about all of the things that we can't explain with this stuff.
Maybe people are like listening in the first couple of minutes and be like, should I keep going on this one? So like should people know, like a regular web developer, should they know how to run their own servers? It seems like we're seeing this massive pushback towards people going back to the server. And I think a lot of that has to do with this whole, you hear people say ZIRP, zero interest rate. What's the P of ZIRP? But what is it? ZIRP, zero interest rate policy. That's the actual name of it, is that a lot of these services for hosting your websites, for hosting your databases, they are all raising their prices right now. And that's because a lot of the investors are saying, all right, interest rates are up. I need you guys to start making money. So like, what do you think, David? Do web developers need to know how to host their own stuff?
I mean, I think it's becoming definitely more prominent, and the answer might be yes, because, we've always had this trade-off to make. Now, first and foremost, I'm not a web developer. I've been a back-end developer for over 20 years, always worked with infrastructure and bare metal, and only recently started to dabble in a little bit of web, but mostly TypeScript, and using it in other domains that it isn't traditionally applied. But what I'm seeing is that conversation about capital expenditure is changing. Serverless used to be the thing that TypeScript developers and web developers could get away with for free forever. And it was just, I never have to pay for a server. I deploy to Vercel and Netlify or Render, Fire, whatever, right? And it doesn't cost me any money. I could scale infinitely, but really it doesn't work that way. These things get stupidly expensive the minute you go past that free tier, if you hit that free tier. And the costs come charging pretty quick. So, it's one little bit of a story and why it might be interesting for people to learn more about bare metal and hosting their own stack. I used to work for a company called Equinix Metal, formerly Packet, and their product is cloud infrastructure, but you get a full bare metal machine. Like when I do demos for people, I'm running a 1 meg binary written in Rust that needs about 2 kilobytes of RAM, and I run it on a machine with 128 gig of RAM and 78 cores, right? Just why? Because it's fun, right? So finding the ability to use that hardware, not at that scale, controlling your stack from top to bottom, will reduce your costs. Now, the point of that story of why I worked at Equinix Metal is I used to help a company called LogDNA, who had a £1 million per month bill with AWS. And by moving to bare metal, they got that down to under 300,000 per month, which is still a lot of money, but it's a 60% reduction in cost. So once you get past those free tiers, maybe you need to analyze and work out where you need to be hosting your stuff.
When people say bare metal, like what does that mean explicitly for people who might not know?
Sounds sick.
Yeah, it does.
When you have compute and memory and I/O all in a little square box or maybe a rectangle box stuck into a rack and you SSH onto it with no virtualization whatsoever. So of course, every cloud provider has bare metal, but you don't interact with it. You work with the virtual machine, the hypervisor that you're given. Bare metal means there's none of that. You're working directly with the CPU, etc. So.
Oh, okay. So like when you sign up for a GoDaddy account or a DigitalOcean droplet or something like that, there is some beefy server slapped into a rack somewhere, and you're running your code on the same box. It's in its own container, virtualized Linux container, but it's actually sharing the CPU with other people who are on the same box, right?
I mean, I'll say yes, but I'm going to go into that with a little bit more nuance, right? It's very rare, very, very, very rare that you ever get a Linux container as your environment because, you know what? People don't trust you. And I know that may come as a shock, but containers are great because we get access to Linux namespaces. This means we don't get visibility of all the processes on the host. We don't have access to we shouldn't be able to see the entire file system or memory and all this other stuff. But these providers can't run that risk that you're going to go poking and find a breakout of that container. So what actually happens is whenever you get a VPS or a virtual machine on EC2, DigitalOcean, they're actually running a hypervisor layer, Zen or KVM or something else, which gives you a virtual machine, and then they stick your load, perhaps still in a container, but within the virtual machine, because they need that kernel level isolation, meaning they don't trust you speaking to the host kernel. You're going to get a little kernel there. They have a better sandbox.
Oh, so it's two levels. You have a container inside of a VM on a Linux box. That's right?
Very standard setup, yeah. And this is how Chromebooks work as well. If you've ever tried to use the Linux mode on a Chromebook, it's a Linux host with a virtual machine with your containers inside of it. So, yeah.
Oh, interesting. And that's because they don't want anybody monkeying around with what could you possibly do if you have straight access to the bare metal? Like delete the CPU?
Well, not that you'll be able to delete the CPU. Are we talking about the Chromebook use case here or in the cloud?
Well, just in general, like if someone does give you access to that low level stuff, you can do nefarious things, right? Or you can break things that would cause a lot of support.
For definitely, right. Let's cloud use case. So let's assume I'm a cloud provider and I say, hey, here's a container on my bare metal. You've got access to the kernel. Go nuts. Now, in theory, I've done things right, and I've mapped the root user away so that you don't have access to root user. I've given you a confined file system. You've only got a restricted view. You've not got any process ID table stuff. All you see is a very small part of that. However, the code that you execute is still executed against the host kernel, meaning if you have a 0-day or some exploit that you've established on your own, and you could speak to that kernel, you could ask for it to give you all the files. You could ask for all the memory. You could inject CPU instructions into other processes. There's a whole bunch of malicious and nefarious activity that you could do. And that's why that extra layer of Zen or KVM is brought in at the cloud provider level.
When you're hosting actual bare metal, are you still going to a service provider like Hetzner or something to host on bare metal, or are there the companies that prioritize bare metal over, typical virtualized private servers?
Yeah, there's not that many cloud providers that are willing to give you a bare metal box for a few different reasons we can get into. The biggest one is Equinix Metal. They were formerly called Packet. You may have heard of them under that name. And they've built all of their own tooling to do this. So they have this project that can, when you click a button and say, give me some bare metal, it wipes the disks, installs the operating system, and gets it to you in about 90 seconds to 2 minutes, which is just unbelievable for what you're actually getting. There are some other providers like Hetzner, there's Scaleway and OVH. They all offer some bare metal that you can have access to. And last year, 2 years ago, AWS started offering their metal instances as well, especially useful because you can get them with the Graviton ARM processors, which are wicked powerful.
You can go even further, right? Like we've seen 37 Signals. They literally just went to Dell and bought a couple Blade servers, and then they they obviously have a rack somewhere at a like a data center. Maybe you could run it in your office. I don't know. Can you?
Of course, yeah. I mean,
Yeah.
this is how things used to work. We always used to have cupboards in our offices, and we'd run a small 16U rack with a bunch of machines in it, and you stick an IPv4 on it. Obviously, those are expensive these days. But that aside, yeah, you can run your own bare metal. But there's always a catch. It's economies of scale. 37 signals, they can afford to do this. They've got such high costs in the cloud that they're always going to save money. LogDNA have such high costs, they're always going to save money. Regular company building a startup that just spends less than 10 grand a month on a cloud bill, that's the most cost efficient way to do it until you get to that certain scale, and then maybe you kind of step back and change things.
At a certain point, it makes sense. Like, oh, we can hire somebody at 100, 200, 300 grand a year and pay for the actual servers to sort of maintain this thing because it's going to be cheaper than shelling out for some other service. Yeah.
But that's not to kind of dismiss the challenges of running bare metal either. Having done this a lot over the last 20 years, storage is really hard to get right. We take things for granted these days with the cloud, like, having unlimited storage on S3, having super fast NVMe disks that we can disconnect and attach to any device on the cloud within a region, etc. Doing that in a bare metal environment, very painful. Very, very painful.
Oh, yeah.
And that's me not even getting into Kubernetes yet. That's just storage on one or two servers. And then when we bring in Kubernetes, where workloads become ephemeral and they transfer, they move around, and the storage has to go with it. Like, data has gravity, and that gravity pulls hard. So you've got to be really careful there.
Man, well, let's get into that then. What the hell is Kubernetes? Can you tell us lowly JavaScript developers what that weird word means?
So, all right. Kubernetes is a container orchestrator. It is a supervisor that you say, run my container for me, and its job is just to run that container. If your container exits or crashes, it will restart it. If it needs access to certain permissions, to certain disks, to certain networking policies, it will attach them. And at the very basic level, that's all Kubernetes does. You just say, hey, run my node application in this container for me, and then you don't need to worry about it.
Okay, and why would somebody need Kubernetes? Is it because they need to scale their infrastructure easily, or like what's the benefit of using that versus just SSH into the box, curl whatever node, run the app, and you're off and running? And obviously, sometimes I get people mad at me on Twitter because I say these things, and obviously I know why, but I'm asking for the audience here.
All right, let's picture a world where you're both running Syntax Cloud, right? You've got your two machines. You've got one in your basement, another one in Scott's. You want to run your node application, and it crashes. So you've just run container run. You go to sleep. It fails. Your alerting kicks off. Sentry's going nuts. Somebody's got to fix that, right? So who's getting paged? Which one of you is it? So someone has to wake.
Definitely me.
So someone has to wake up. And then they have to go into the SSH and they have to restart it. And then okay. Now, anyone listening who's familiar with containers will say, hey, there's restart policies. All right, cool. Or someone else is sitting going, hey, there's systemd. Like, we can use that as the supervisor. Right, okay, right, I get it as well. However, all of these are bound to the context of one single machine. And Kubernetes doesn't make sense to run on one single machine. Kubernetes makes sense is when you have more than one machine. When we then have to say, okay, we've got these workloads that we want to run. They can run on any of these machines, and if it crashes, it might be best just to move it to another machine because maybe there's something wrong with this one, and we'll isolate it, we'll coordinate, whatever. We'll fix it when we wake up because nobody likes getting woken up at 3 a.m. And then we carry on our business and schedule it somewhere else. Kubernetes, as soon as you have more than one machine, you really need to start paying attention to it. And I know that in the front-end world, the web world, it's not been something that's been coming charging at people. But if you look at the cloud landscape right now, look at AWS, look at Azure, look at Google Cloud, Render, Digital, I could name every one of them. They all offer a managed Kubernetes service. And that's because in the back-end world, it has taken over. This is now the de facto way to run a container-based workload at scale with resiliency and redundancy. So we can't avoid it, unfortunately.
Yeah.
So you have a central Kubernetes instance that is then orchestrating amongst other other machines essentially and other hosts?
Yeah, kind of. So Kubernetes is split into kind of two phases. There's the control plane and there's the worker modes, the worker plane. The control plane consists of an API server, a data store, which is typically etcd, a controller manager, a scheduler, all these fancy bits that decide where things run and how to fix them if they go wrong. You push that into the managed side, so you're using AKS, EKS, etc. Then all you've got is a fleet of worker nodes that just want jobs to run. And those are the parts that you probably interact with as a developer that wants to schedule a container.
Okay. And so we can use, that was one of my questions, is like, Kubernetes is not just for I'm running my own servers, but if you want to go with some of the less featured, just raw hosts out there, Google Cloud Platform, AWS, IBM, all the big ones out there, you can use Kubernetes to spin up instances on those different cloud providers. That's a pretty common thing?
Yeah. So you can just ask any of these cloud providers to give you a managed Kubernetes control plane. They handle all the hard stuff. The scheduler and the data store, the etcd, like etcd in itself is an absolute monster to operate, even beyond Kubernetes. So.
Oh, sorry, what was that? Say that again. SCD?
etcd, ECD. It's a key value store from HashiCorp. I think they were there. No, they built Consul on top of etcd. Yeah. CoreOS, I think they built etcd.
Okay. Man, and does Kubernetes help with, like, let's say you get a massive spike in traffic where you need to increase the amount of compute that you have, or maybe you're machine learning, you're like, okay, we need to process this stuff for like 3 days. We need like 50 servers to be working on it just for 3 days, and then we'll spin back down to our normal workload. Does it help in those instances where you just sort of need compute on demand?
Yeah, definitely. There's a whole bunch of projects in this space. So let's again assume you're going down the managed Kubernetes. Like as much as I love doing Kubernetes and bare metal, like I'm a complete masochist. I do not recommend anyone listening to this goes down that path. Actually, on my YouTube channel, I have a show called Clustered, which is where I actually spun up bare metal Kubernetes clusters 2 every single week and gave them to random people on the internet and said, go break them. And then we fixed them live, which was scary but fun. Anyway, yeah, don't do it yourself. Use a managed service. And the way that those work is they have something called the metric server that runs on Kubernetes that monitors all of the workloads, memory consumption, CPU. It can also monitor for the scheduler being unavailable to schedule something. So if you say, hey, run me 12 of these, and it can't schedule them, these are all signals to the control plane, or at least to a cluster autoscaler, which goes, oh, we need more compute. And it'll go away to the cloud provider and say, give me 10 more servers and schedule your workloads. And then when there's over provisioned, it will start to scale back down over time as well. So you get to really define the scale up and scale down policies. And it depends on how big that credit card is and who you're working for.
Yeah.
I've been fortunate with some companies where I can say scale up 100 nodes and then scale down 10 every hour, and that's okay. But some places you're like, oh, maybe just scale up 2, and then we'll scale up 2 more if we need. But then it all comes down to how many nines you need at the end of the day for your application. If it's user facing, maybe it's internal. Can you handle 8 minutes of downtime per year, or can you handle 80 minutes of downtime per year? So.
Oh, man. That's actually one thing. Very rarely does my schooling come into play, but I went to school for information technology management, and that was one of the big things, the nines. What is it? What's the 8 nines, or what's the 9 nines? What's the most popular one?
You're not getting 9 nines, but 5 nines is probably
5 nines. That was it. And 5 nines is how much downtime per year?
I think that's like 8 minutes. Hold on, let me Google that. I should know better. I should know my nines by now.
Downtime less than 2.25 minutes per year, or 5 minutes and 15 seconds. So 5 nines is 99.999% uptime. So it's only okay for your application to be down for 5 minutes and 15 seconds per year, which is that's a lot, man. Like I can't think of any apps that have not been down for less than that every single year, you know? Like, do you know any apps that have maybe not gone down? Like, I think even Google has gone down at certain points.
Yeah, well, I mean, measuring this stuff is all a bit kind of put your finger in there and hope for the best. Status pages never accurately reflect what's actually happening with these applications. So their status page says they've got 5 nines, but realistically, they're doing worse than that. But then it comes down to let me go slightly off tangent here, is that it comes down to what you define to be an outage, right? Now, in a microservice architecture, which you most likely have, because we call that the cloud native architecture if you're deploying to Kubernetes, then if a service is down for 10 minutes, but your end user doesn't see any regression in performance or accessibility or anything like that, usability, it's not really an outage. So we don't count it. Of course, if google.com front page is down and people can't search, that's an outage. So that's where we apply like a S1, S2, S3s. That's a severity rating. And outages, generally if an S1, they'll wake you up, you fix them. Those go against your 5 nines, and everything else, you're built for resiliency. You architect for failures so that they don't affect that overall.
Okay. Yeah. So I told the story a couple of months ago how one of my apps was crashing, but it was only crashing every 3 hours or so. And I run 3 instances of it. So, and it restarts in like 20 seconds or something like that. So like, I was like looking at it and I was like, I'm going to go to bed because it wasn't actually ever down. One of them was down at one point for 20 seconds, but there was never any overlap where all of them were down at the exact same time. And that's, I guess, one of the benefits of doing this type of thing, right? Like you said, if one goes down, then Kubernetes will know to maybe move that to another location because maybe that server has gone bad.
Exactly. You take your high value containers, and Kubernetes, we call these deployments, right? A deployment says, I'm going to run one or more containers for you. We identify the things that do have some sort of uptime guarantee, or we have, we can attach money to, right? Every time a user gets this and it's down, like Amazon, that costs them millions if they're down for a minute, right? So those things, you're going to over provision. You're going to say, okay, we're going to run 200 of them. We only need 150, but we've got a 25% capacity there if we need to in the event of an error. So,
yeah. So when you say container, okay, to give the audience perspective here, can you give just a basic, what is a container? Does that inherently mean we're talking about Docker, or is Docker just a type of container?
So containers existed before Docker, but Docker were the pioneers. Those are the ones that made the tooling easy. So it's quite common for people to say Docker container or Docker, and they just mean a Linux container. And that's fine, right? Call it whatever the hell you want. But what a container actually is let's try and imagine you're sitting at your terminal, right? You've got your shell open, Z shell, fish, whatever you're using, no shell, and you type ls. When you type that ls, you're listing all of the files that exist in a file system. That ls itself is a process that runs on the kernel, and it consumes some sort of CPU and memory. A container says that we're going to isolate that process so that it can't see other processes, and it can only see the file system that we give it. And even to the point where you can change the time zone within a container and say that it actually believes it's in Los Angeles instead of being in Glasgow for whatever reason. These are all called namespaces in Linux. So, process, there's mount, which is file system. There's a user timespace timeshare namespace, which is like the time and date and all that stuff. And all we do is give a very simplified view of a system. So to the point where you could run ls/, and typically you'd see a root file system. But what if that root file system was only the root file system within your container? And that's what's actually happening under the hood. You can even be root in a container, which is UID 0, but in the host, you're actually UID 67,512. So there's loads of really cool things happening there within the container and the way that Linux namespaces work.
And what do you like using for containers? Are you into Docker?
I run Docker on my Mac for sure because it handles the VM layer so that I get Linux native containers. It's got good Rosetta support. So, I'm on an M Mac, which means I can't run a lot of container images that are built for AMD 64. Docker's great. But in a server environment, I use Containerd. So we are talking about Kubernetes. Let's just provide some more background context for anyone who's not familiar. Kubernetes is a graduated project within the Cloud Native Computing Foundation, the CNCF. Containerd is the container runtime for Kubernetes. It used to be Docker, it's not anymore. But even Docker itself is using Containerd under the hood, which in turn uses runc. So it's this hierarchy of layer of abstractions. So yeah, Containerd on the server, Docker on the desktop, and then there are loads of other tools. You don't have to use these ones, but these are the main ones that most people are familiar with. The reason so many people use Docker is they literally invented the Docker file. And building these containers was really hard prior to 2013. The Docker file came along and made this a very simple text file where we just do Docker build and we get a container image spat out of the other side, which is pretty cool.
Oh, that makes so much sense now. So Docker is just a way to interface and create a Containerd, and then a Containerd can be put anywhere via Kubernetes on different infrastructure. Is that correct?
Okay, let's bust out some more vocabulary because there's not been enough yet, right? Docker is a command line tool that you can execute commands. If you do Docker build, it builds something that we call an OCI artifact or image. This is an Open Container Initiative project. So because Docker made this popular, they kind of controlled the spec, and then other people were like, hey, we've got container runtime. So they all work together on OCI. And now we have OCI images, which can be executed or run by any compliant container runtime.
Okay.
Yeah. It gets complicated very, very quickly because there's so many moving parts underneath.
Yeah, but probably not something like, is that something if you're going to run your own Kubernetes or a hosted Kubernetes on AWS, is that something you really have to care about? Do you have to get into that?
No, just build a container image and ship it. That's all you need to care about.
Cool. Yeah. Now, I'm curious about WASM because WebAssembly is a technology that allows us to run different languages kind of in a container in the browser. And then recently we've been seeing people take the WASM tech and move it to, you shouldn't just have to run it just in the browser. It should be able to run anywhere, kind of like a container. So do you have any thoughts on that and the tech around that?
Yeah, I am fully invested in WebAssembly now. So let me try and, again, provide a bit more context. There's a really great quote from Solomon Hykes. Solomon Hykes was the founder, or at least one of the founders of Docker. And I'm sure he's going to yell at me for bringing this up because I think he wants to forget he said it. But he said on Twitter, so it's public domain, that if WASM and WebAssembly had existed in 2013, there would have been no need to invent Docker, which is such a powerful statement, right? Now, the reason I'm still doing Kubernetes, I'm still doing containers, right? There is a certain type of workload that has to be in that space. But what we're seeing now is there's a lot of workloads that don't need everything that comes with a container. And those can run in a WebAssembly sandbox. Now, WebAssembly runs in the browser, has no access to networking except for like the fetch API. It has no access to file systems. It can't do anything that a real application or a node application would need. But that's where WASM comes in. So this is the WebAssembly Systems Interface, which provides a POSIX-like API for WebAssembly workloads. And as of really recently, a couple of weeks ago even, there was the WASM Preview 2 announcement. And this is the first time the WASM spec has changed to support something called the component model, which we'll get into. The component model means I can take a WebAssembly binary and I can run it, but I can enrich it with new features. I can give it access to TCP, UDP sockets. I can give it access to file systems. I can give it access to wherever I want. And to the point, the component API is so flexible. I could say, I'm going to give you access to a key value API. You can say get and set. And then you have no idea what powers that behind the scenes. It could be Redis. Where this gets more powerful is the operator of that runtime and the components can swap out your Redis for Kafka, MongoDB, whatever they want, and you never need to know. So we get this kind of onion architecture that we can apply to our applications. And then us as developers, all we focus about is our application needs these APIs to run. It speaks to something, we don't care what, and we store data, we fetch data, we do whatever we have to do. So WebAssembly and WASM, Web Preview 2 becomes a very powerful platform for running stuff with a few key benefits over containers, right? Now, I won't ask you to show by hands, but I'm assuming you both built a Docker container at one point in your life, hopefully.
Unfortunately, yes.
Yes.
Scott and I are both kind of Docker camp because it's just a little bit painful every now and then, but yes, we have.
All right. So there's lots of things you have to bear in mind when you build a Docker file, right? You've got something called layers, which affect the build cache, and those layers are additive. You can never delete something in a layer to reduce the size of the overall container artifact. So if you do like an apt install Olama LLM 17 billion gigabyte LLM model, and then you run your command, and then the next layer you say delete all that, your image is still going to be that huge, massive size. And people learn this the hard way, unfortunately. On the other side, WebAssembly binaries are teeny tiny. The last one I shipped to production was 5 meg in size, versus the average container size is hundreds of megs, if not gigs of megs, which I see all too common. Then is the really cool thing is that the startup time for a container, now if you've done Lambda or any serverless container-based environments, you've heard of the cold start problem. The cold start problem says that in the worst case, this container may take up to 200 to 300 milliseconds to start. Do you know what the startup time for an invocation on a WebAssembly module is?
What?
We measure it in nanoseconds, not
seriously?
Milliseconds. Yes.
Wow.
So if you can ship small megabyte in size binaries with a startup time measured in nanoseconds, your serverless platform just got a lot more interesting, right?
So if I'm understanding, like I'm trying to understand, like what would somebody want to use WASI for? Like a WASI container, or is that what they're called? WASI containers?
They're just WebAssembly binaries, artifacts.
Yeah,
it's not really
WASM.
like a conditioned name.
So let's say like I have a Rust script that will do some processing of a file and then kick it out the other end. You're saying like it's not a Linux environment, right? So you don't have access to TCP and file system and all that stuff, but these new things you're talking about are going to allow us to have new APIs for saving data, file system, networking, et cetera. Is that right so far?
Yeah, those now all exist with WASI Preview 2. We have components for networking. We have components for file and disk access. This is now standard, and you can do that today with Rust, with TypeScript, with Zig, etc.
Okay.
Wow. Are people shipping this like currently to production, or is this still all?
Oh yeah, definitely. There's some really amazing platforms out there to make this work. I think one of the key selling points, besides the stuff that I've already said about the size and the invocation speed, is that if you've worked with Docker in your local machine, it's a good experience, but it's not a great experience, especially for node applications where you have to mount in a file system and then the reloads could get really slow. Mm-hmm. But those disappear. And also this architecture. I'm on an M1 Mac, and the container image is built for AMD 64. Everything's broken. I can't do anything. With WebAssembly, all that disappears. There's no virtualization beyond the WebAssembly runtime itself. So things are native, which means we can mount stuff in. We can run them on any machine. The same WebAssembly workload I compile on my Mac, I can give to somebody running Windows or Linux on a different CPU architecture, and it still just runs the exact same.
That's what blows my mind, is that it's easier for me to npm install ffmpeg and run it in WASM than it is to brew install, but if you're on Windows, do this and all these things, and it's a different version. And as long as somebody has built that process for WASM, it will run literally anywhere that runs WASM, correct?
Exactly, yeah.
And what other kinds of things would you put in WASM? Like maybe video processing would be one, image resizing might be another one, but like what else are people using it for?
I mean, I'm just building standard applications. Like the last thing I shipped to production was a URL shortener. And
really? Yeah.
It's just because it's so easy to do, and I get to work in my own, like I like writing Rust code. And the fact that I can compile that Rust to WebAssembly natively without any extra hoops to jump through is quite nice. And then you just deploy it to a platform that supports WebAssembly, and then it's online, and I can just use it, which is
okay.
Yeah, it's just nice. And the tool chain's the same locally. I'm building a Rust application. I'm not building something for a container. I'm not building something for Cloudflare workers. I'm just building a Rust app that happens to be shipped as a WebAssembly module.
And we had Jake Champion on, who works at Fastly, and he took SpiderMonkey, which is a JavaScript engine, and compiled it to WASM, and then he takes your code and puts it in there as well. So you can write languages that cannot be precompiled, right? As long as you ship the compiler with it, or sorry, you ship the runtime with it. Like, can I put JavaScript in a WASM or WASI file?
So, I mean, yeah, you could, definitely. However, JavaScript has really good, and TypeScript has really good support now and runtimes that compile that to WebAssembly without having to ship an interpreter with it. But for languages that don't, let's go back to the classic PHP, right? We've all written it at some point. But VMware has really led the charge on compiling the PHP compiler interpreter to a WebAssembly module. And then you can just mount all of your PHP code into it and run it, and it runs in a WebAssembly module, which is just wild to me as well. To the point where you can actually do a script or in a web page, pull in that exact PHP compiler that is a WebAssembly module, and then have a script tag with PHP code in it, and it runs in your browser.
PHP in the browser, yes.
Script
if
type
you search for
PHP
PHP-WASM, people have actually run Drupal 7 in the browser via the WebAssembly interpreter.
Wow.
Why? I mean, why not?
But like that, I know that stuff's silly, but it really makes me understand like what WASM actually does, And
people have compiled a lot of
over
things in the browser. You can now run Git in the browser. Someone compiled Git into a WebAssembly module. There's SQLite. There's a whole bunch of really cool stuff happening.
Yeah, we just, the episode before this, we just talked about the SQLite adapter that interfaces with IndexedDB, but it's running in WASM. Yeah. Wow. That is so cool that you can do this. And obviously it doesn't just have to run in the browser, it can run anywhere. And that's what WASI is, right?
Yeah, so WASI just gives us that component model where we can layer on the functionality that the browser is never going to accept because it is a secure sandbox for applications. There's many runtimes as well. There's WASMer, WASM Edge, WASM Cloud. All of these things run WASI workloads on your traditional laptop or server infrastructure.
Wow. And how would just a regular person go make a WASM image? Is that just something like would Scott and I ever make a WASM image, or is there going to be like images out there that already been created for the type of stuff we want to do? Like, I'll give one example is we have like a Rust script in our code base that populates a testing database. So if you want to run it locally, right? And Scott has to compile that in order for it to run, and he has to ship the compiled version. But like, wouldn't it be cool just to like run the Rust code directly via WASM?
Yeah, you could definitely do that. You just update your Rust toolchain, you add the WASM WASI32 to the port, you change the target when you compile it, you get a module, and then you execute it with WASMer, WASM Cloud, etc. And as long as you've got the right components in place, which admittedly is not as plug and play as we'd like right now, but that spec is very new, right? WASI Preview 2 is a few weeks old. The easiest way right now for you and Scott to get started would be to check out a project called Spin by Fermion. This is the batteries included easiest way for anybody to start writing WebAssembly today. And it's got an SDK that provides key value storage, networking requests, everything. They're also helping lead or contribute to the WASI 2 preview spec. So they're implementing it as they go.
But
Wow.
there's probably also like a Rust interpreter that has been built into WASM that we could run, like if we want to run it on demand, because that's what we had somebody on from the Node.js project. And they said, we're pretty close to being able to just import a .rust file or something like that. And if you have everything set up properly, it would just interpret and run it without having the tooling set up on your computer. I just think that's pretty cool.
Possibly. I mean, I'm not familiar with that effort, but I'm not surprised either. I mean, coming from my perspective, Rust is so easy to compile to WASI. I've always just done it that way. But it makes sense to provide a very simple runtime for that, because anyone who's written more than one Rust program knows the Rust compiler is very slow. And we spend a lot of our times doing the SKCD thing, spinning about our chairs with swords.
Oh, that's cool.
Spin is pretty neat. I've put the link in our show notes here for anybody who wants to check this out.
Yeah, they've really simplified that whole developer experience side of building WebAssembly applications. And then you just do a spin deploy and it sticks it on their cloud and it's like readily available. I actually wrote an application that was written in Rust, and I encoded all my information into it. And when you hit the URL, it spits out like a VCF contact card for when I go to conferences. And it's just this WebAssembly module is my business card now, which is kind of cool.
Nice. Yeah.
Can you? I don't know if you know anything about this, but I'm always curious about the difference between like a Intel or AMD processor and like an ARM 64 processor, right? Like our MacBooks are M1, M2, M3. Those are ARM chips, right? Are servers, like what do servers use? Do they use both? Is there a benefit to using one over the other?
So traditionally, servers have always been AMD 64. That is the instruction set that they kind of use, the architecture that they use. But, ARM has really changed the way the world thinks about computing with RISC. RISC is reduced instruction set computer. They basically condensed everything and said, we don't need all this stuff, let's simplify it. And they've just been leading the charge on making that fast, really, really fast. There's something called SIMD, which is a really pushing beyond the realm of possibility, which is where you have a single instruction that runs on multiple types of data. So if you get your compiler right, something that Rust does really well, it can optimize for these things, for the architecture that you're building to. And then the real selling point of ARM over Intel is just the power consumption is drastically less. We live in a world now where we have to be very careful about our consumption of the planet's resources, green energy, and ARM really makes a significant dent in server infrastructure there, which is why it's been so heavily pushed.
Interesting. Yeah, because I got a DM on Instagram after our last show on this stuff, and he said, hey, check this out. He's running this thing called a Turing Pi, which is and he'd slotted like 8 Raspberry Pis. The Turing Pi runs Kubernetes, and he's able to like have this like botnet of it's obviously not a botnet, but like able to have like 8 different computers running all at once as a home server. Instead of one beefy server, he has 8 Raspberry Pis running at once. Have you ever looked into that?
Yeah, one of my friends, Alex Ellis, he's very big into this. He's got his own Pi hat and he runs 8 of them as his own home automation and infrastructure thing. It's never been something I've dabbled into. I've always had access to chunky Equinix metals. I've been a bit spoiled in that regard.
Yeah.
But yeah, there's a really strong person. He works with ARM stuff that you should probably chat to. I'll drop his details in with you later. His name is Daniel Magnum. He can go into that in ridiculous detail if you want to chat about ARM stuff at some point.
Cool.
Yeah. What are people running on these things if you have a Pi cluster in your home office or something like that? I know Wes and I both run like NAS drives with all sorts of containers. But what are people doing on this stuff out of their house?
A lot of what I see, when I go to KubeCon and such, is people are running Home Assistant, and then they're getting they're having a lot of fun just automating as much of their home as possible.
Yeah.
A lot of people also hook it up to webhooks from different, cloud providers, GitHub, whatever services they're using, have them hit their home machines, and then they build more automations on top of that. Discord bots, Slack bots, whatever. It's just a really simple way of experimenting and building cluster-style compute at home, which is quite nice.
Yeah, from this guy that I was talking to, he was saying, like, I run all my home server stuff on it, and it's a really great way to learn Kubernetes because you're not running a single server with a single process. You're running 8 different processes, and you can kind of understand how that works. And I could also see it being like really handy. Like I run a home media server, and those things will transcode video as you're watching it. So my kids are watching it on their iPad, and it'll transcode it in real time, or pre-transcode it, right? And sometimes if you have a couple people streaming from it at times, you can get some lag. So wouldn't it be nice if I had an army of servers in my basement here that could just increase and like the Kubernetes would say, oh, well, hey, move this streaming task to a different process.
Yeah, I mean, if somebody's streaming and the device supports, 640p, that's fine. Everyone can knock themselves out. You can have 12 concurrent connections, but then you always got that 4K person, and then everything falls over, and then you're like, oh crap, I need to scale this up now. And that's exactly what Kubernetes does. It brings a whole bunch more to the table, but the easiest way to think about it is, it runs one or more containers and scales them for you. So.
Mm-hmm.
Yeah. Next thing you know, you got a home lab, you're on home lab YouTube.
Yeah. Building a supercomputer. But like, that's also what I saw is I've seen people build supercomputers where they just do, instead of doing one big computer, it's millions of low power devices, right? Like imagine taking all 8-year-old Android devices and plugging in, I'm talking out of my butt right now, but imagine you took like all the phones that nobody ever wants anymore and they still have chips in them, right? Like imagine you slotted those all in and were able to architect them. I'm sure somebody's doing that.
I mean, just all of that old hardware out there. I'd hope someone's putting that to good use through some other means, definitely.
Yeah. What do you have?
Maybe like one of these browser testing companies that offers you like a mobile view. Maybe it's just running on like a 20-year-old Android device somewhere. Who knows?
Yeah.
Do you have a home server set up yourself, or are you running everything in somewhere else?
I've got a couple of mini PCs on my desk that run a combination of Linux and Windows. The Windows I don't really turn on too much, but now and again I do like to try and do a bit of gaming. And with the Linux side, I've really been experimenting with container-based desktops. So traditional Linux would be like run Ubuntu or run Fedora. But there's a really cool project called Universal Blue and Bluefin, where the actual kernel starts and then runs a container which provides your desktop environment. And then if you ever want to modify it, you update the Docker file, essentially. Say add this new package and reboot, and then you get a brand new, fresh machine every time, which is kind of cool.
That's cool. Yeah, I often wonder about that, running my own, like VS Code. A lot of people are running it in the browser and they run it on their own infrastructure. And you obviously get the editor UI, but you also get like a VM with it where you can run your backend stuff on. And I often wonder, like, wouldn't it be cool? I think it's called Code Server or something like that. Wouldn't it be cool to like learn how to self-host my own version of that?
Yeah. Hey, it might fit in well with the offline first stuff that we were talking about earlier today. I think, because we are getting kind of close to the end here, I do want to get to one quick topic really quick before we start to, change course. But if people are interested in trying out Kubernetes, like they hear this and they say, this is something that's interesting to me. Where do you even start with this stuff?
So Kubernetes.io is probably the best place. The documentation is pretty feature complete. There is a challenge with Kubernetes. It's a very fast-moving project. They used to do 4 major releases every year. They've now dropped that to 3 because people kept complaining it was too fast. But the documentation is, they've got a great team that work on that every quarter and keep it up to date. So I would go there. The tutorials are fantastic. I'll also say people should just check out the Raw Code Academy, which is my YouTube channel. I've got like 400 hours of Kubernetes and cloud native content there. So if you want, it depends how deep you want to go down a rabbit hole, right? If you just want to learn Kubernetes 101 and get your first deployment going, go through the documentation. If you want to understand how the container runtimes work and the control plane and etcd and what happens when these things break, then go check out my channel. There's another really good website called Kube Simplify and one more called Learn Kates. These have phenomenal resources on them as well. So.
Sweet. We'll link those up in the show notes for sure, because it's RAWKODE.academy for anyone trying to type it in right now.
Yeah, I mean, Kubernetes is complex, right? There's a lot of moving parts. It's very volatile. It changes. You have to learn at least a dozen resources that you deploy to a cluster just to get one workload working, really, if you want to do it proper at production grade. And the only way to learn that really is just to get hands-on. So really, you just need to get your cluster. Use Minikube, use Docker Desktop, whatever you want. Get a cluster locally and start kicking the tires on that thing. Write your first deployment, write your first pod, get your first service, and take it step by step from there.
Nice.
One more thing I wanted to touch upon is this idea of infrastructure as code. And we've had Brian LaRue on a couple times. He's big into that as well, where you define what your infrastructure looks like via code, right? Like you can check it into your code base. It's in some sort of config file. But you took it one step further to something I've never seen. Your DNS, all of your records for your domain name is as a text file on your GitHub, so that if you ever lose it, and it cuts down on this thing called ClickOps, which is like, to set it up, you have to log in and click these buttons and add these permissions. So how do you, can you talk about infrastructure as code a little?
I can. I mean, I'm hoping to be at a conference a JavaScript conference this summer where I have a talk called Deleting Raw Code Off the Face of the Internet, which is where I delete every one of my DNS records and my domains live on stage.
Wow.
Because I have a lot of confidence in my automation. So I automate everything. I actually wipe my machine every 30 days and restore it. So I wrote a Rust project called Comtria that takes a YAML interface for all my applications and my dot files and provisions them for me.
Whoa.
But that just does my machine. I was like, oh, well, what about my email? What about my DNS? What about all my domains? So then I started I used to work at Pulumi, so I was using Pulumi for a while. But I'm now using Terraform CDK, which is using TypeScript with Terraform to do the same thing. So I've got it hooked up to Cloudflare. I say, here's all my domains. I give them all my records. And literally I just do CDKTF apply or deploy. And it goes and checks everything is correct. And if not, it reconciles them and then shuts back down. Now I can run that 10 times a day. I could run it once a day. I could run it 14 times an hour, whatever I want. It's always going to make sure that what I want actually exists. And it's just a really powerful way of doing it, to the point where I could go on stage at this conference, delete everything with a CDKTF destroy, show people my website doesn't work, they can't email me, my URL shortener's broken, but within 10 minutes have that all spun back up exactly as it was before.
Amazing. Do you talk about that at all on your YouTube channel? Because I am very interested in learning more there.
Yeah, I've got a few links on infrastructure as code and using these tools. I'll definitely share them with you as well, so you can check that out.
Cool.
But it's really easy to get started. And what I love about this, right, is because it's TypeScript. You know, one of the things that bugged me about Terraform is when it comes to duplicating code, you have to do it all the time because it has no concepts of really reusing stuff beyond modules, and modules are a huge pain. But with TypeScript, I can literally just say, I have a function on my helper class called enable Google Workspace. And that sets up the MX records, it sets up the DKIM, the DMARC, the SPF, all of that. Wow. It just takes the key as a parameter and it's all done for me. I've got enable, Cloudflare CDN, enable Fastify. I've got enable Sentry. Whatever I want to exist is just one function away, and then I can apply that to any domain within my stack. And it just becomes really powerful when you build your own abstractions that fit exactly the model that you have in your head, and then apply that to the world.
Man. And that doesn't nuke like your data, right? Like your files in your database?
No.
No? Okay.
I mean, if I do a destroy and I have a database that is provisioned, it's gone bye-bye. Yeah. But then hopefully I've got backups. And if you do it right, you can restore, you can do everything that you need to in code because you can define whatever workflow you want. So it's a very powerful model, and you can do a lot with it. And the nice thing is, there's a Terraform provider for everything. It doesn't matter if you're using Porkbun, Cloudflare, GoDaddy, whatever. There's probably a Terraform provider. I mean, there's a Terraform provider to odds of pizza. So, I mean, I'm pretty sure we can manage our DNS. Yeah, someone wrote a Domino's Terraform provider. Highly amusing. Not practical whatsoever, but, if you want a pepperoni pizza, why not infrastructure as code it?
I think I saw some TikToks of a guy, like, live coding to order a pizza in, like, so many different ways. And one time he got two showed up. It was two separate orders, so obviously there was a bug somewhere. I'll see if I can find it. That was hilarious.
Yeah, I mean, a happy bug. He got two pizzas, but I'm sure he spent twice the money. So always unit test your infrastructure as code as well. That's important.
Oh, that's great, man. Like, this has been so enlightening in terms of like what this whole side of the world looks like, which is, it's funny because like I've been a Linux computer user. I've ran servers. I've had home servers for more than half my life. But when it gets into like actually larger infrastructure stuff, like real stuff that matters, it's a whole different world. So it's interesting to see that this stuff is so accessible, and also with all the WASM stuff getting better as well.
Well, let's have a closing thought for myself then. Let's cross the streams. Kubernetes, like I said, it's not going anywhere. I still write containers. I still ship them to Kubernetes. But there is a really growing presence of changes within Kubernetes to support WebAssembly workloads natively. So Docker themselves wrote a shim called Run WASI, which is a containerd shim that can execute WebAssembly modules as if they were containers, but they're not containers. That can now be run on a Kubernetes cluster, and then you have two different types of workloads that can be scheduled. That's Kubernetes to run your containers here, here, and here. But you can also tell it to invoke WebAssembly modules on demand based on routes coming into your cluster as well. So the world, hopefully the future we get in 6, 12, 24 months is a single control plane that everyone should learn now, Kubernetes, that can run a multitude of workloads, whether that be WebAssembly, maybe even JVM. Yeah, there's a big movement right now with Graal native as well. So why not run that on our Kubernetes control plane with our WebAssembly modules and our containers, and things get particularly interesting. So,
after years and years of laughing about not understanding Kubernetes, I think I've reached the point where I want to learn it now. So thank you, David.
Job done. Awesome.
Yeah.
Beautiful. Yeah, thank you so much. We'll move into the last section, which is a shameless plug and a sick pick. So we'll start with the sick pick first. Did you bring anything that you'd like to sick pick?
Yeah, there's been a new project that I discovered just this week that kind of touches on everything that we're talking about. It's called Golem Cloud. And what they've done is they're hooping in to the durable execution thing that's happening right now. Everybody seems to be talking about durable execution. And they've said, okay, well, let's flip this on its head. And they've given us, you write your code, compile it to WebAssembly. We'll run it on our bespoke orchestrator and give you durable execution to the point where you can say sleep for 2 years. And that WebAssembly module will be invoked in 2 years' time, right where it left off with the same state, which is just magic in my book. It's by the people that built ZIO for Scala. So these are people that are big into functional programming, and that comes to Golem too. So you get like this actor-driven workflow system with durable execution with WebAssembly, and it's just, my eyes lit up when I found it. It's like, this is the coolest thing I've ever seen. It's super early. Nobody should go and adopt it in production right now, but go definitely check that out.
So like you could like literally pause the thing in the middle of a function, calculating, and whatever is in memory and would all be saved, and you'd be able to resume that? Yeah.
Like, it's for building workflows, where previously you'd have to say, okay, quit this workflow, and in 2 years' time, start me a new one with this date. Yeah. Now you just say process.sleep, and then the runtime understands, okay, let's just pause and checkpoint this, and then come back when the time is up. And then your workflow is just a single function that defines everything that you need to do, even though it runs over days, weeks, months, or years, which is really cool.
Yeah, that's cool. I even wonder if you could use that for like a queuing system as well. You know, sometimes you put something into the queue and you say, all right, in a week from now, run this and check if they've done X, Y, and Z. And if not, then do something.
You could implement a queue in their state and it would be checkpoint. Another project that's trying to do exactly that, though, is called restate.dev. It's built in Rust, because all these things are. And it has something called a keyed service, which can act like a queue. It processes things sequentially, one by one, with whatever workflow characteristics you want. But now I feel like I'm cheating and giving you 2 sick picks.
No, I'm like saving
picks,
links left and right here.
There's lots of links in this episode. Me and Scott have been going crazy finding these links and putting them in there.
I'm actually mad because you got both of these last 2 before me, and I was like, I had them on my clipboard. I was ready to paste them in, and Wes jumps them in there.
Cool.
Yeah, and what's really interesting, all these things are written in Rust, but they all provide a TypeScript SDK, which I think is really cool.
All right, shameless plugs. What would you like to plug to the audience? You can have as many as you like.
Really just my YouTube channel. Go check out the Raw Code Academy. Like, if you've suffered through this episode long enough to hear me say Kubernetes and WebAssembly, then my YouTube channel is the right place for you to come and learn more. So just check that out at rawcode.live or youtube.com/rawcodeacademy.
Cool.
Wicked.
Yeah, we'll link that up.
Thanks so much for your time. Appreciate it, all this information.
No, thank you for having me. It's been weird. Like, this is the first time I've ever heard both of you speak at 1x, because I listen to podcasts.
Yeah, we get that a lot, especially in person. People are like, wow, your voice sounds different IRL. You're not at 2x. Yeah. Cool. All right.
But yeah, thanks. Thank you so much. It's been fun. Cheers.